friends, welcome back to Math Defined. It's time to put what you've learned about comparing and ordering rational numbers to work with some practice. And if you'd like to work these out on paper with me, there is a printable worksheet for this practice at mathdefined.com. So grab a pencil, get settled in, and let's get started. Let's start with these first 6 problems about absolute value. You're going to pause the video and solve this group of problems on your own first, and then we'll come back together and check the answers. As you work, remember this. Absolute value tells you how far a number is away from 0. And if there is a negative sign outside the absolute value bars, make sure you find the absolute value first and then apply the negative. Go ahead and pause the video now. All right, let's check your answers. Problem number 1, the negative absolute value of positive 5. This problem has 2 steps. Start with the absolute value first. The absolute value of positive 5 is positive 5 because it's 5 units away from 0. Next, apply the negative outside the bars. So the answer is negative 5. Problem number 2 is the absolute value of negative 7. The answer is positive 7. That's because absolute value is all about distance from 0, and distance is always positive. Number 3, the absolute value of positive 2/5 is positive 2/5. Number 4, the absolute value of negative 10.8 is positive 10.8. Remember, first find the absolute value, which is the distance from 0, then look outside the bars to see whether a negative sign changes the final answer. Moving on to number 5, the negative absolute value of negative 8/11. First, find the absolute value of negative 8/11. That gives us positive 8/11. Now apply the negative sign outside the bars, and the answer is negative 8/11. Another good reminder that the negative sign outside the bars still matters after you find the absolute value. And finally, number 6, the absolute value of positive 3.25 is positive 3.25. All right, let's move on to comparing rational numbers next. This time, you're going to compare numbers and decide whether the symbol should be less than, greater than, or equal to. A good strategy here is to simplify each side first before you compare. Go ahead and solve all 3 problems on your own, and I'll see you back here in a few minutes. All right, let's see how you did. Problem 7 is comparing the absolute value of negative 4 to positive 4. First, simplify the absolute value of negative 4 to positive 4. Now we compare. Positive 4 is equal to positive 4. Moving on to number 8. We have 2 absolute values to simplify. Starting on the left with the negative absolute value of negative 1/4. First, simplify the absolute value to positive 1/4, and then apply the negative sign outside the bars. On the right side, simplifying the absolute value of negative 5/8, we get positive 5/8. So now we're comparing negative 1/4 to positive 5/8. And this one is easy because a negative number is always less than a positive one. Problem number 9 has a negative sign outside the absolute value bars. So we'll simplify inside the bars first to get positive 5.2, and then apply the negative sign. So now we're comparing negative 5.2 to negative 5.2, which we know is equal. Let's move on to ordering rational numbers. Go ahead and order these numbers from least to greatest. Remember to simplify the absolute values first and then compare. All right, let's work through this together. The first thing we want to do is simplify the absolute values. Starting with the absolute value of negative 2.5, it simplifies to positive 2.5. Next, we'll simplify the negative absolute value of positive 3 1/4. It simplifies to negative 3 1/4. And lastly, the absolute value of positive 4 1/3 is positive 4 1/3. I'm going to organize this list of numbers by bringing the last two down. Now we're ready to compare. First, we'll compare the negative numbers, since we know that they are always less than the positive ones. Negative 5 is less than negative 3 1/4, so negative 5 is the smallest number in the list, followed by negative 3 1/4, but we need to write it in its original form, the negative absolute value of positive 3 1/4. Moving on to the positive numbers. It might seem a little overwhelming at the moment because of the variety of numbers and denominators, but all we really need to do is look at the whole numbers. There's a 2, a 1, and a 4. So the next smallest number in the list is positive 1.5. Then positive 2.5, or in its original form, the absolute value of negative 2.5, and finally, the absolute value of positive 4 1/3. Wow, that seemed like a lot, but you did it. Our last problem shows us some math in action. Your friend is at the shore of the Salton Sea in California at an elevation of negative 236 feet. You are in Oklahoma City, Oklahoma at an elevation of 1,201 feet. Who is closer to sea level? Go ahead and pause the video and think it through first. All right, to figure out who is closer to sea level, we need to know which elevation is closer to 0 because sea level is at 0 feet. So this question is really asking which number is closer to 0 on a number line. That means we use absolute value. For Salton Sea, we'll find the absolute value of negative 236, which is positive 236. For Oklahoma City, we'll find the absolute value of positive 1,201, which is positive 1,201. Now compare those distances. 236 is less than 1,201. That means that negative 236 feet is closer to 0 than 1,201 feet is. So your friend at Salton Sea, California is closer to sea level. This is a great example of how absolute value is helpful in real life. It helps us look past the positive and negative signs and focus on how far each place is from sea level, so we can make a fair comparison. Nice work today. You showed up, you practiced, and that matters. If you're ready to keep going, like this video and subscribe to the channel, and head on over to mathdefined.com to continue with the next lessons on adding integers. I'll see you soon, and until next time, keep math awesome.